Now let's take a look at the components we are using in this project. This right here is an AT89S52, which will be the brain for our entire process. This AT89S52 helps us to use these loads connected to the 4-channel relay by operating in 5 volt and converting it to an AC signal for the loads connected to it. And then the modes are selected using the 6 push buttons we have right here, which are connected to the input pins of the microcontroller. And we have made a 6 clock circuit using an oscillator, a 10 MHz oscillator and a 2 capacitor. And then we have a reset circuit connected to the microcontroller. And here we can see an LCD, 16x2 LCD, which can display 32 characters at a single time. And to maintain a specific contrast, we can use a potentiometer to vary the contrast of the letters displayed in the LCD. Now let's get into the working of our project right here. So for giving an input signal for our microcontroller, we are using a 5 volt signal that is generated by the Arduino, powered by DC source. So when the 5 volts gets transmitted to our microcontroller, it starts working and lets us operate in 2 different modes, namely the auto mode and the manual mode. In manual mode, by pressing the polling button, we can operate every stage separately. When I click the first button, the first stage of our process gets executed, the second stage of our cycle, and the third stage. And this fourth button allows us to turn off the entire cycle. And now once again, we are given with an option to switch modes, whether an auto or a manual mode. By clicking the respective buttons, we can switch between modes. Now let's dive into the code that's been flashed into our microcontroller.
So guys, for this project, we are using MicroC IDE for writing the code. So guys, as we talked about earlier, we have seen the circuit connections. Now let us walk through the programming part of this project. So step 1, LCD pin connections. First, let's look at how we are connecting the LCD to the microcontroller. Here we are assigning the LCD control and data pins to specific bits of port 2 of the 8051. RS and EN are control pins, while D4 to D7 are data pins in 4-bit mode. Let's come into the step 2. Now we are in the main function. We initialize the LCD, turn off the blinking cursor and clear any previous content. Then we display this message on the second row, which is nothing but S1 is equal to manual, S2 is equal to auto. It is clearly indicating while pressing the switch 1, we will be in manual mode, while pressing the switch 2, we will be in the auto mode. This tells the user that pressing S1 will be manual mode and S2 will activate auto mode. Step 3. Setting up inputs and outputs. We configure port 1 as input with pull-up resistors. This is where the push buttons are connected, and port 3 is configured as output, where we connect relays to control the bulbs. Setting port 3 to 0xFF turns all relays off initially. Step 4. Now let's understand how manual mode works. When button S1 is pressed, which is active low, we enter manual mode. Inside this block, we check other buttons S3 to S6 to control bulbs 1 to 4 respectively. Now S3 of P1.F3 is double equal to 0 turns on bulb 1 connected to relay on port 3 F3 pin. Similarly, S4 of P1.F4 double equal to turns on bulb 2 on port 3 F4 pin. Each block clears the LCD, shows the status like bulb 1 is equal to on, and activates the respective relay by setting its pin to 0, which is nothing but on, while keeping the others off. After a short delay of 1 second, it checks again. Okay. Now let's go to the auto mode. Step 5, which is nothing but the auto mode logic. Now let's understand the auto mode. If P1.F1 is double equal to 0, this is the initial condition, which is nothing but when button S2 is pressed, we enter auto mode. The LCD shows auto mode and then a timed sequence runs. Bulb 1 of P3.F3 is turned on for 1 second. Similarly, bulb 2, bulb 3 and bulb 4 will be turned on. Each bulb turns on one after the other with a fixed delay, then turns off before the next one activates. After all bulbs have run, there is an additional delay of 1 second before the loop restarts. So this is all about the coding part. If you ask why we are using MicroC, we have to convert all this code into a hex file, and this hex file has to be dumped into the microcontroller for the further operation as we seen before. So thank you.